we'll start this one. So I've been a designer using Solidworks for a decade and a half, give or take. Most of my time these days are spent doing consulting on behalf of Smooth Logics around the country. That's always exciting. I grew up in the manufacturing environment, so I have a strong background in making things and all that. Nights and weekends, I adjunct at the local school here north side of town on Thompson MTech Center. I know some of you are here for extra credit that I promised you. I've been in a few different industries, which is a lot of fun because due to the consulting, you know, right, every place around the country is somewhat different, so that's always fun. You get the variety. Married with a 3-year-old son and a 1-year-old daughter. I just need another bullet point. It kind of looked like white space, so I just added that. I don't really know what that has to do with SolidWorks, but that's the great thing about doing the presentation, right? You do what you want. So I'm going to quick go through my PowerPoint and kind of just talk theoretics for maybe 5 minutes, and we'll get into the software and actually start explaining things. But one of the course of the tips and tricks is basically, well, we're going to talk a little bit about just how to do it faster. But most of what I'm going to talk about is how to do it smarter. And predominantly, how to do something in a smart way so that future changes don't break things. So how many of you can like draw really, really fast? Okay, medium fast. You're good at drawing things. Okay, but the challenge that I run into a lot with different customers throughout the country is they can draw things pretty effectively, but then if there's a minor change, it takes half of that much time to make that change. And a lot of things break and a lot of things blow up, and then you redraw a bunch of things, and everything is crash-tastic, and you don't know why. So that's really what we're going to focus on a lot. Those of you that have been in any one of my classes, I pretty much have one universal rule, which is a 2-part rule. Rule number 1/2 is everything will change, and because everything will change, everything will break. Who lives in an environment where you get explicit requirements, you design them, and then you never change it again in your life? Right? Nobody. That's not our lives. If it was, a computer would be doing it and not us. Right? So while we're designing, we really want to focus on the work that I'm putting into the SolidWorks model will change from a definitive standpoint, not if. And I understand this is not a 100% case scenario, but from a thought process standpoint, we want to be thinking about when this changes, what will happen. So rule number 1, everything will change. Rule number 2, or the second part, everything will break. So some of the logic that we work through here is everything will change, not if. And so when something changes, what's most likely to change? So if I draw a table, what's most likely to change on this table? Probably not the thickness of the wood, but probably the size of the table, the radiuses, the chamfers, something like that, right? The wood is probably pretty consistent from a probability standpoint. Wood could still change. And then of what's most likely to change, what's the most probable change? So assuming the outside diameter of this table changes, what's most probable? Am I going to go to square corners or maintain my radius? Well, if I have something tied to that radius and I go to square corner, what I just tied to that radius is now going to break. Right? Because we have our everything is a parametric model, so we have our parent-child relationships, and we have to build through our tree. So then based on the most probable change, what will be affected downstream? So that's the first half of the rule. The second half of the rule is now we're downstream of what's affected, what's most likely to break. And we think about that even before I draw a sketch, and I'll verbally explain some of this as we go, once we get into the software. And then of what's most likely to break, what can be mitigated? So if I think about it and say, you know, there's a high probability that hole isn't going to be there. When that hole's not there, what's going to happen? And when that happens, can I mitigate that? Can I take a step so that something doesn't break? And can I think far enough ahead in the future to slightly affect my behaviors today to make my design more robust and reliable later? Where am I? I hate PowerPoints, but I thought it was the best place to start. So of what can be mitigated, is the effort worthwhile? There's a lot of people that will take a good idea to an extreme, and the amount of time you spend in that good idea far outweighs the amount of time you saved implementing that good idea. Right? So if I spend an hour, oh, I wrote that. If I spend an hour to mitigate something to avoid a 5-minute fix, you know, I've wasted 55 minutes of my time. So we always still have to balance ROI. At the end of the day, it has to make sense, financial sense, because that's what we're all paid to do. And then also keep in mind, not all SolidWorks errors or breaks are created equal. There is sometimes I'll set up the models to intentionally break. So for example, you could mate things in such a way that it would never ever break. But then your model will not update properly. So sometimes I want the red error, I want my mate failure, I want my feature failure, because if I didn't have that failure, something worse would happen. Right? Sometimes a failure is a good thing, and we'll look at that. And then basically the general theme is we're going to think through and theorize on ways to limit our liabilities. We don't want, when I design something, I want the least amount of liability possible, and liability being something that could go wrong, right? So I've got more slides, but let's jump into SolidWorks. The first thing that I often lecture about and talk on is your origin. If I'm going to draw this table that my laptop is sitting on, where should that origin be? Absolute middle, all the time, right? Because the reason is if I put the origin on the edge, it doesn't really bring me any value. My 3 planes are where? On the edge. So having an origin in the corner here with my 3 planes all in the corner isn't driving me any value. So there is a chance, and this is not guaranteed, right? But there is a chance that having the origin in the center will provide some value. So for example, there's screw holes on the bottom of this table, and with an origin in the center, I can now use the origin for symmetry, right? Because I got the plane. So the first thing I would like everybody to realize, or what I try to lecture on in school, is planes are incredibly valuable. So where you put the planes in your model will drive value or remove your value. And planes are the most reliable. That's in the next section. But planes are incredibly reliable unless I delete a part. So if I have a part in an assembly and I mate to that plane, unless I delete the part, will that mate ever fail? No, because I cannot delete my planes. So in the ecosystem of a part file, your plane is the most possible reliable thing in the world. Nothing will make that plane blow up because that plane is undeletable. It is the absolute base foundation of our 3D parametric model. So, for example, if I design this table and I say it's going to be, I don't know, 6 foot, and we all know that we can type in units, right? So I can do 6 foot by 3 foot. So I can type in 3 and the single quote symbol, which is foot. And when I hit enter, SolidWorks will convert it to me for 36 inches. So I hate doing mental math. I actually don't hate it. I like mental math. But every time I've done mental math against the computer's always won. Okay? That's what SolidWorks is really, really good at. So if I have to design these hybrid metric environments, which, who all hates metric? Yay! Okay. So if I have to design hybrid metric environments, and they tell me it's 1200 millimeters, I'm going to do 1200 mm, enter. So tip number 1. So there's a mixture of speed tips, and then there's a mixture of stability tips, right? So speed tip number 1, SolidWorks has a full unit converter built into the software. Yes, sir?
I'm going to expose myself to be really slow. So you did a single click and created a box around the center. Are you going to tell us how you did that?
Yes, so there's another presentation. So I'm extremely heavily vested and encourage keyboard shortcuts. So for example, we'll delete all this. And I deleted all that, sorry. Start from square one. Microsoft Windows has a set of standard keyboard shortcuts. So who knows what Control A does?
Select it all.
Same thing in SolidWorks. If I hold down Control A, it picks everything in my sketch. And then I can hit the delete key. Okay? Because most everything in Windows has transferred into SolidWorks. SolidWorks did a very good job doing that. Same thing, I can hit Control A, Control C, and then Control V and paste it over. Right? Control C for copy, Control V for paste. It's universal. So in SolidWorks, you can assign any keyboard shortcut to pretty much do any function that you want. And I have a litany of them, and I'll gladly share them with you. My contact information is at the end. So I have Control R for center point rectangle, and so there I have my center point rectangle. I never went to a toolbar. I have S key for smart dimension, so I can type in 6 foot by 3 foot. I have E for extrude, and so a lot of my commands will be 1.5 inches. That looks like 1.5 inches. A lot of my commands will just spontaneously happen because I have a keyboard of 26 characters Plus, you can use Alt, Control, and Shift combinations. So my my sketching, I have R for rectangle and the Control R for center point rectangle. So that's, you don't have to use my keyboard shortcuts, just use some. And that's kind of one of the points later is, by my estimation, about 30 to 40% of all design time is spent in the sketching environment. Right? Everybody generally agree with that? So the number one major consumption of your time in SolidWorks is sketching. So if there's a single mode that you could make faster / more reliable, there's no better bang for your buck than sketching. So when I was an uber nerd, and I've slowly digressed in my nerdism over the years, when I was an uber nerd, I kept track of what commands I used for an entire week. And then I ranked them on what was most frequent, and that's how I determined my keyboard shortcuts like 13 years ago.
That gets the chicks then.
So I realized something lately. We're going to get slightly political because this is just funny, but you know the phrase chicks dig scars. So I've recently chicks dig scars. So I recently bought a scar. I also like guns, but neither here nor there. So my keyboard shortcuts are optimized for the kind of work I was doing at that time, and I have just kept that for 13 years, and I've gotten good at it. None of my keyboard shortcuts have anything to do with sheet metal, because I didn't do a lot of sheet metal at that time, and I do now, so I click on sheet metal buttons because I'm not flexible enough to remap my brain. But the interesting thing is, whether it's sheet metal, whether it's surfacing, whether it's 3D design, whether it's molds, tools, robots, anything, everything has a sketching foundation. Everything. So whether it's sheet metal, I can still optimize the 40% of my time in sketching, even if I'm doing sheet metal or mechanical design. It's all relative. So back to our design, back to our table. So I have a table with my origin in the middle, okay? And okay, we got 4 bolt hole patterns. I didn't look at that prior. I probably should have. The other thing we want to do is design everything in use position. I use in use position because some of us do tools, some of us do machines, some of us do product. Right? So if I'm going to design a computer speaker, I'm not going to design it upside down in my SolidWorks environment. If I click on the front plane and hit normal 2, I should look at the front of whatever I'm designing in normal use. Now sometimes that's not always practical if it's like a bolt, right? If it's a bolt is a bolt. But if I'm doing something of physical, tangible relevance, like a table, it should be in use position of SolidWorks. So if I'm going to put the bolt holes to bolt the legs onto my table, I want to click on my top plane and hit normal 2 once, and I have a keyboard shortcut for normal 2, and hit normal 2 a second time. Now I know I'm looking at the bottom of my table. So now that I'm on the bottom of my table, I'm going to start my hole wizard. I have a keyboard shortcut for that. It's U. And say I'm going to put tapped holes probably actually don't work very well in wood. So we're just going to do a fractional hole of 1/4 inch. We're going to use self-tapping wood screws. We're going to go down 1 inch in my positions. All right. Now I got to put positions on here, and I want to limit my liabilities. So when something changes, how much effort am I going to have to take to maintain that change? Right, so my boss comes and says, here's the legs we're going to use on the bottom of the table. My boss will guaranteedly come back at some point before the project is done and give me different legs to use. Right? We can all relate. So thinking about that and looking into your crystal ball future and saying, when this changes, what is the least amount of liability I can put into my design? So let's walk through it. I know I have to have 4 holes. And so I'm going to connect those with a center line. Another interesting thing is in SolidWorks, you can do keyboard shortcuts for pretty much any command. One of the commands is make horizontal, make vertical, make equal, make collinear, make tangent, right? These sketch relations that we all should use and love. So I drew a line between 2 of my points, and that line's not horizontal, but I need it to be horizontal. So on my keyboard, I have H for make horizontal, and I didn't leave my line command. I clicked, click, click. I tap H on my keyboard, it's now horizontal. I can go up to this line, tap Y or V for vertical on my keyboard, and it's now vertical. I never left my center line command. Not once.
Just double check. Those aren't keyboard shortcuts you set up. Those are
Oh, no, those are mine.
Oh, those are yours.
There's nothing I'm going to tell you that's a stock SolidWorks keyboard shortcut.
Ah.
I'll freely give you mine. I don't care. I mean, mine aren't right. They work for me. Now, everybody who takes my classes uses mine. Because when I stand up in front of 20 people and I say L for line and let's draw a line, I don't want 30 different, or can't have 30 different, but I don't want 10 different line commands. And most people coming to my class have 0 keyboard shortcuts, so it's really easy to just, suck them into the fold. But I encourage you guys just to use whatever you guys use. I mean, keyboard shortcuts will make you faster. Mine won't make you faster any better than Rick's, any better than Jim's. Relatively, right? If you have really crazy keyboard shortcuts for like Simulation Express that you do once a month, then you miss the boat. But that's the general thing. Okay, so the bolt hole pattern for my legs are a square bolt hole pattern. So in no way, shape, or form do we want to put 2 dimensions on here, because I have now doubled my liability. Right? If I say 12 inches by 12 inches, my boss comes to me and says, here's a new leg pattern, and they're 14 by 14, 14 square. I now have 2 sketches, or 2 dimensions that I'm liable for. Right? So I don't want that. General rule, we'll go back to my PowerPoint here. I think it's here. Ah, yes. Okay, so if you have 2 dimensions, and these are not going to be in order, if you have 2 dimensions with the same value in one sketch, optimize. Now, it's not a guaranteed. Sometimes I legitimately need 2 discrete values because one value is doing the offset for the trim and the other value is doing the size of the hole, right? So it's not a universal thing. But specifically in this context, I want to select these 2 lines. I have Y for make equals, and now they're equal. Now when my boss says new bolt hole pattern, I have 1 value to update. You need to limit your liability. And this is also good and readable. So if I give my design over to Henry, and then my boss goes to Henry because I got fired because I'm difficult to work with, and Henry says, no problem, I'll change it for you. No problem at all. And she misses one of the dimensions. I didn't set it up right. And then we get a rectangular bolt hole pattern, right? That's not good. So it's readability, it's reusability, it's being able to hand off the design to somebody else. All of this is limiting your liabilities. All right, I also need a bolt. There's 2 legs on this table, so I also need the same bolt hole pattern on the other side.
One other question, Andrew,
yes, sir.
In regards to that. So we also draw so that when we throw it into a dimension drawing, that comes out that way. So
oh, absolutely not. You're welcome to leave if you if you want to do that. So I'm pretty adamant on this because I should be modeling to it boils down to separation of concern. When I'm modeling, my concern is that the 3D geometry is good, I have limited my liabilities, and it's readable and maintainable. A 2D drawing is a totally different discussion, a totally different separation of concern, and in 2D, my number 1 and only goal is to make the drawing as manufacturably friendly as possible. So I'm never going to compromise my 3D design because of a dimension I want on a print because the machinist needs that dimension. Right? You want your, it's like wanting your car to hold more capacity, so you cut the roof off of it. Okay? I mean, long term, you're going to be much more happy with a roof than that slight increased capacity once a year. Or I can't think of a better example.
No, that's fine. I understand where you're going.
But, I didn't really plan on getting into 2D drawings, and I don't know. We'll see how long I ramble, and we'll see what second session holds. Maybe we'll get there. All right. So I want to limit my liability. I want my legs in the middle, right? Always. Everybody wants table legs in the middle. That's not up for debate, right? So I don't want to add a dimension and go like this for several reasons. One, it's mental math. And what do we do about mental math? We don't do it. That's what we do. And so if when something changes, when this 36 changes, now what did I do to my sketch? What is my liability? I have to do more mental math, which I'm not going to be as reliable as the computer. And I have to type in a second dimension, which is wholly unnecessary. So how do we position this in our y-axis in the center all of the time, no contest?
Center line.
Center line to
Midpoint.
the origin. So what happens if my origin was in the corner? You could make it midpoint to the edge, but how reliable is that edge compared to the origin? That edge can very easily disappear and blow things up. That origin will never move because the origin is foundational to the part. So I'm going to take a horizontal center line. Well, I say horizontal, but I drew it on an angle because not everything is drawn perfectly. So I hit my H key, and it's magically horizontal. And I now have the legs aligned in the y-axis exactly in the center, which is the design intent. It's never going to change. So I now hand this print off to Jim, and the boss comes over and says, this is now supposed to be 12 inches, and he types in 12, and his liability was a single dimension. There's nothing else that has to change. Yes, sir?
Is it better to put the center line in, or just to align the center point of your other center line with the origin?
Yes, so it is possible, right, to click on that center point, and SolidWorks 2016, I think it was, made that really easy to do, and click on the origin and hit H. By a simple glance at the screen, who's going to tell me how that's aligned? Okay, readability. Nobody is going to question. Nobody's going to question this. Everybody can look at that and instantly understand how that's constructed. The bigger challenge, and this isn't bad, but the bigger challenge is if I'm zoomed in here, I have a horizontal to what? Right? If you get a more complex sketch and you have 100 sketch relations on your screen, it becomes a bitch to find. Probably shouldn't say that while this is being recorded, but I've said worse, so whatever. What are they going to do? Fire me? So we've got that.
Would you be better to have a diagonal going across and you use that? Now you've got a distance.
Diagonal like no. Okay, I'm sorry.
In your sketch that you have there of your whole location.
Yep.
Get rid of your line that's in there.
All right.
Go from the bottom left corner to the upper right corner.
Okay.
Now from the midpoint of that over to the origin.
Yep. So perfectly acceptable. Accomplishes the same thing. I'm not arguing with that. It's one extra line that I'd rather not draw because I'm an incredibly lazy person. And you're indicating now that I have a distance off the center line, right? Right. So from the center of the table to the edge of the leg. I would suggest that most dimensions, if I'm going to dimension the space in this leg, I'm probably going to want to go from leg to leg. Leg to center probably isn't optimal. Does that make sense?
Yes.
If I was designing okay, so when I designed office furniture.
Basically the center line of your leg is the center line of your post.
Right, but I probably want to have a dimension from this leg to that leg, not from this leg to the middle.
Right. But that right now, you have not nailed that down.
Nope, I haven't.
Where that's at.
Yep, so the next thing is, how do we intelligently get this placed where we want, and I still have another set of leg holes I need on the other side? So how are we going to limit our liabilities and have good design intent that's readable that I can hand off so other people can pick it up really easily? Mirror it. So what do I need to do to mirror it? I need another vertical line. And by the way, I've gotten so lazy with sketching, and my keyboard shortcuts I found so convenient that I don't even bother to draw a vertical line, because it's a lot easier just to draw a line down somewhere and then instinctively hit V. Just that's my laziness showing through. So I now want to mirror this over, but I really only want to mirror my points. Okay. So if I was thinking, and this is we're trying to do progressive thinking here. If I was thinking when I started the sketch that I wanted to mirror it, I would have done my sketch totally different. What would you guys have done different?
With the holes in?
Well, we're putting holes in right now with the hole wizard. So this is what I would have done differently with my sketch. I would have done point, 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 mirror. Because I can box select 4 points without any of those lines. So everything about CAD is optimized, or if you can optimize everything about CAD in macro movements, it'd be far faster than micro movements. If I want to individually pick on 4 things or box selecting is always faster than individual picking. So part of, I guess that is one other thing here. So in 2017, Solidworks introduced shaded contours for sketches. And I just turned those on, and we'll get to those in a minute, and we'll talk about that.
Are you hitting the H key or do those automatically go to horizontal?
Nope, I'm hitting H key. Yep. It's pretty fun, huh? Okay, so I want to go center line to center line. How do I do that now with the sketch geometry I have?
Equals?
Equal what? Huh?
Dimension from
One side
the
equals the
other.
other side?
Dimension from one side to the other. So I could go like this to this, right? As long as I favor the left-hand side on both, I'll get what I want. Okay? Not very readable. I've got a dimension that's skewed, but it theoretically works. And I could say I want 48 inches center line, right? So it's fully defined. Everything's black. It's theoretically okay. The one thing I don't like about that is when everything changes, what's the first thing you do when you change a sketch that has a mirror in it? You totally delete whatever you just mirrored. And then you fix your sketch and you remirror it. So part of my liability of all future changes is more than likely I'm going to delete whatever I mirrored.
Dimension from that and pick the center line and go to the other side of the drawing.
Exactly. So I can dimension from this midpoint, pick the center line, and everybody knows on a smart dimension, if you have a point or a line selected and a center line selected, if you move to the opposite side, it'll give you a double dimension. So this is like, this is especially helpful if you're doing a revolve. Okay, so if you're doing a revolve and I pick my outside edge of my shaft and my center axis that I'm going to revolve around, I can double my dimension to get a diameter in a 2D sketch from a 3D revolve. And that happens universally in SOLIDWORKS. So any point or line, it doesn't work with 2 center lines because SOLIDWORKS doesn't know where to double. So it has to be a point or a line, and then you can double your dimension. So I can place a dimension here, which is also 48. And now I can give this to anybody in this room. Henry, Jim, anybody. I'll read random name tags. Brian. And the boss comes over and says, our table like bolt hole pattern is now 10 inches, and I want them 40 inches apart. Right? Anybody in this room could figure that out. I've got 2 dimensions. I've got 8 points on the screen. It's very readable. It's very good design intent. All the dimensions are logically where I want them for the construction of the geometry. So we say, yep, that's good, and go. And I've got 8 holes. Sir?
Pardon the interruption. Maybe
No
we'll
worries.
go backwards here, but one of the things that you said is that if we knew that we were going to mirror our holes, we would draw the holes first and then mirror them.
Yep.
But then you went right back through and did the exact same setup to those 4 holes.
Yep.
Rather than just mirroring everything.
Well,
Why is that?
yeah, so I mean, I started over from scratch just to demonstrate. I probably wouldn't have at that point because it would have taken more time to start over from scratch to redraw it. So that was just a demonstration. But let's pretend this mirror disappears, and I love that I can delete my mirror without losing my dimension. Right? How many people wish you could do that all the time? Well, now you can. So if I had done this and then realized I needed it, I would just box select these 4. And the only reason I'm box selecting, holding down control and box selecting, is because it's easier to box select macro movements than hold down control and pick, and then you pick the wrong one, and then you unpick it, and then you pick the wrong one, and then you unpick it, and you pick that wrong one and that wrong one, and then, so it's just a lot easier to box select.
What's the downfall of box selecting the lines?
Oh, I'm sorry. So if you go like that and hit mirror,
Yes.
SOLIDWORKS has no idea how to mirror because I have 5 center lines selected. So if I do my mirror command, it's going to say, hey, we'll mirror all this stuff about what? Oh, I want to mirror about this. And then I get a lot more geometry than I want. I only want 4 points. It's the only thing I'm interested in.
If you put points there instead of the original box, you had, but then you want to have to do the lines anyway in the box. Can you tell me why?
Well, I did it poorly the first time. I deleted it all and did it the optimized way.
You still intended to have a line.
Yeah. I'm
Is the construction line and the center line just
the same thing.
Exactly the same thing? No differences?
No difference. It is frustrating to me that even in the Solidworks software, it's not consistent. So if I click on the line on the left-hand side, we have for construction, so it's a construction line. If you go to launch the line command, it's a center line. So a center line is a line for construction, and a line is a center line not for construction. It's really frustrating. And those are the... It's recorded. Just watch it on YouTube a few times. So if you draw a line and you want it to be a center line, you can click on that line and use this construction geometry button, or you can check the for construction box. If I go to my line command and make a center line, it's the exact same thing, just called two different things. It's really frustrating. I have my gripes with SolidWorks, and one of them is their naming or labeling conventions. They're not consistent, and it's frustrating.
So you could theoretically use a center line as a construction line in any place it's not a center line.
They're identically the same thing. It's there's no different. It's like, is it GM or General Motors? Well, it's actually Government Motors, but that's a different discussion. So we're gonna make our holes. All right, so we'll save this to the desktop called tabletop. Wow, that was, I don't know what happened there. That was cool. Oh, that's right. I have a touch screen. I forgot about that. I wiped dust off my screen. New laptop, not used to it. Okay, so now we're going to draw some really, really terrible legs because I don't really have the time to do a good job. So we're going to start drawing the center leg column. So we'll go top plane because I want to draw everything in position. So here's the shaded. I just turned this option on. This is a new SolidWorks 2017 option. It's on by default. Drives me batty. But it shades all of your sketch contours. And we'll get into later why it really frustrates me. But anyway. So it kind of shades all your sketch contours, and it'll do graduated shading based on how many layers there are. So it's kind of clever. But I now want to delete this stuff. So I want to box select. Oh, but you can't. With a shaded contour, you cannot box select inside of it because what SolidWorks thinks you're trying to do is move your sketches around. Which I agree is a pretty fun thing to watch and play with. It's pretty clever. But who actually wants to move their sketch on their screen? Like, in a normal day's worth of work. Like, never. I think I do it 3 times a year. So there's a setting called sketch or shaded sketch contours. And so you turn that off and it reverts to the old versions of SolidWorks. If you do want to move something, you can still select it, right click under sketch tools. If I can read, move entities, and you can still move things around. So you could always move things in SolidWorks. They just made it easier to do something that we virtually never ever do. But with them turned off, I can now box select and delete that stuff. So let's say that table is, I don't know, 3 inches. So here's my 3-inch diameter. We'll do an extrude, mid-plane. Why do we do mid-plane? Because the origin is always in the middle. A plane at the very top where I have a face does me 0 good. A plane in the middle of my part, because my face is my face, right? I can still mate to my face. I can still do everything on my face. So a plane and a face occupying the exact same 2D space provides me 0 benefit. So even if the plane in the middle I never use, I at least have an opportunity for benefit, right? I'm not only limiting my liability. Ooh, I should do a catchphrase. I'm not only limiting my liability, but I'm maximizing my potential usage. That plane will never be effectively used at the top or at the bottom. In the middle, I could potentially use it. So why would we not ever want to set ourselves up for more potential options of use instead of less? So mid-plane, where applicable, is always awesome. We're going to do a thin feature and invert that and call it an 1/8 inch wall because that's really heavy pipe. And we'll say it's 32 inches tall. All right, we'll save this to the desktop. Call it our...
Do you design to the idea you do?
I'm sorry?
Do you design to the idea you do?
That would depend on what stock I have and what I need. But most of the time in this particular environment, what I'm concerned about is the outside diameter. the outside dimension.
Right, but when it looked like when you were doing it, your thin went out instead of in.
No, I inverted that.
Okay.
Nope, so I clicked the little arrows button. I did it just
You got
really...
too many shortcuts going too fast.
Well, so A, that's why it's recorded. B, I only have an hour, people. So we've got our leg, right? And so now I want to design my sheet metal, which this is not. This is cast, but we're on the lazy train today. I now want to design my sheet metal connector. So let's say I want to draw something that looks like this. And we all know we can draw a line, leave the point, come back, touch the point, and come off as a tangent, right? No?
Yeah.
Do I need to do that again? All right, I'll do it again. So with your line command, I draw a straight line. You leave the line, come back, touch the line. It'll come off as a tangent in the quadrant in which you left the line. So here's a tangent, an inverted tangent, a right-handed tangent. And so you can make your tangent, click, and then you can keep drawing lines. Or you could tangent off your tangent off your tangent off your tangent. All right, well, I want both of these to be tangent. So what's the easiest way to make them tangent?
Control select, tangent,
Control select. So I'm going to hold down control and pick two things. What did I just do?
more steps.
Micro actions. What could I do instead? Swipe.
I've always wanted this.
Okay, so I can just swipe. Everybody understands the difference between box select left to right versus box select left to right, right? Okay.
Yeah.
Well, this is not my PowerPoint. These are just freebies, so no extra charge. If I box select right to left, so it doesn't matter if I'm top down or bottom up. All that matters is when my cursor starts on the right and goes to the left, I get a green box, and every single thing inside of that box in any capacity is selected. So both of those are selected. If I box select left to right, I get a blue box, and only things that are wholly inside of that box get selected. So nothing gets selected. So if I go like this left to right, I will only select that arc. If I go like this right to left, I will select anything that was inside of that box.
Is there a way to select both lines and make them both tangent at once?
Well, tangency by pure definition requires
Well, you
two
only do the one.
entities.
You
What?
only do-
Yep. So you can pick two lines, and then we have our quick accelerated make tangent, which will make a tangent. In SolidWorks 2016, I believe, maybe 17, one of the two. I'm running 17, so if you click on just the point, they added make tangent, which is really cool. It's a micro movement. I have to find the point, and then I have to find tangent. My personal favorite is a macro movement, box select left to right, and tap my make tangent key. Because any command in SolidWorks you can tie to a keyboard shortcut. It's really cool. All right, so we're going to draw one more line here and connect those. Pick my origin, and in this instance I control selected, right? Pick your origin and that. I have another keyboard shortcut to make midpoint. So you can do make coincident, make equal, make tangent, make midpoint, anything you could have ever imagined.
How do you
But-
make a midpoint without the short keyboard short?
So a midpoint by definition is a line and a point. People make the mistake of picking 2 points and trying to make a midpoint, right? That can't work. So if you pick a line and a point, in this case the origin, there is a midpoint relation, which is a line with a point in the middle. There's a coincident relation, which is the line is touching the point, but it can go along the line. Those are the accelerator menus. Otherwise, there's the old way of doing it on the far left-hand side. Or you can just hit your favorite make midpoint keyboard shortcut. So here I want, let's say, a 20-degree taper on that. And now I want this to be at a 45, right? Because my leg's in the middle. I've got my bolt hole pattern. So I need this top mounting plate to be on a 45-degree angle. How do I make a 45-degree angle in SolidWorks the easiest, best possible way? And I want to limit my liability, right? When do I ever want this as, sorry? Dimension off the plane. Certainly acceptable, right? So I can go right plane and say 45 degrees, right? It saves me from drawing a vertical or horizontal line. So that's most excellent, right? I don't want to draw extra geometry because I'm really lazy. But I would suggest that that's not the best way to do it. Because I have now, every dimension I add is a implied liability. If I add a dimension, it can be changed. If it can be changed, it can get messed up, or it can get edited, or it doesn't communicate design intent as well. It's just an arbitrary value, arbitrary in the pure abstracted sense. If, however, I draw this and make those equal, what have I guaranteed myself? Because if you have a triangle with a vertical and a horizontal line that are equal, I have what angle is guaranteed mathematically. All of the time, every time, no contest, no question. So from a readability design, I can hand this off to somebody, and they're like, well, there's not even a dimension to mess up, right? It's limiting your liability. How much can go wrong, and what can we do to prevent that? So this one here, I'm just going to make that and that perpendicular. I don't use perpendicular enough, so I don't have a keyboard shortcut for that. Sue me. I want this to be a diameter value. So we'll say that is 1.5 inches for funsies. And what was it was 12 inches, right? Yeah. Yeah, I don't remember. We'll figure it out. So here, I'm going to pick on the center of this and my construction line and type in 12. Now I'm a guaranteed 12-inch bolt hole pattern off my one leg, and I'll pattern this. I've got one dimension here that defines how big my mounting pad is for my bolt hole, and one angular dimension. Right, there's a lot of sketch geometry on there to be constrained with just 3 dimensions. But my liability is 3 dimensions. So,
what would be the sensible way from this 33 degrees? Would you just dimension it?
Yeah.
Okay.
I mean, if it was something other than a straight 45 and my bolt hole pattern was rectangular, I'd probably go through the effort of drawing this differently so I could draw the full rectangle. But because this is an exact square bolt hole pattern, and I know that's the intent, and when we talk about, back here, everything will change. We're talking about from a thought process standpoint, clearly not, imperial or in absolutes. So my legs on my table, all the legs I've ever worked with in my entire life always have a square pattern. So in the odds of that changing, the odds are very, very, very low. But the 12 inch to the 14 inch is a very, very high odds. So when I'm doing that, I want to make sure that I have a solid 12 inch here and a solid 12 inch here. If I had 12 inches here and 6 inches on my legs, now what are we trying to do to make a match? Mental math. And what do we absolutely detest? Mental math. Because the computer always wins, right? Every time I've challenged SolidWorks to a competition, it's beat me. So we go to our sheet metal and say, yeah, this is going to be, let's say 1/4, because this is not a light table. And go. And so now we can construct our axis. And let's do our pattern. Bodies. 4 looks good to me. Maybe we want to merge those. I don't think it likes to pattern sheet metal. Oh well. We'll fix it this way. I'm totally doing this off the fly, by the way. This is not a canned presentation, in case anybody didn't notice. So then here I'm just going to add my holes. So now I want a screw clearance. We'll say 3/8 through all. And now when I'm going to place my holes, what am I going to do when I place my holes to limit my liability? Yeah, I'm not going to use a single dimension. I'm going to say there, and there, and there, and there. Go. So far on this part, I've got 3 dimensions plus my sheet metal material thickness. Now let's add fillets. We'll use our cool accelerator menu to grab all 4 of them quickly. We'll add a generous fillet there of 2 inches. And we'll pretend this is done. So this is going to be a table, leg, top. Alright, so let's start assembling this. Going here. And I don't think we're going to have time for the support legs, whatever those are called. So we'll dump this in here. And I'm going to use this in my assembly presentation, so if you're coming back for that, I'll see you then. And we'll build this assembly here. We'll continue building it as we go. Back to my presentation. All right, so origin placement. We talked about that a little bit. 3 planes could be useful or useless. If I throw them down in the corner, if I throw them in some arbitrary place. I mean, I've been around consulting it, and I've seen some really, really weird things, like the origin randomly in the center of a rectangle, the rectangle dimensioned appropriately, and then an arbitrary 8-place decimal dimension from one edge of the rectangle to the origin and the other, because that's where the rectangle was when I drew it. Okay, I mean, just total arbitrary. The planes in that instance are benefiting you nothing. Okay, so the planes always have the opportunity to be helpful. So because that opportunity always exists as a potential, leverage it. The origin location could save dimensioning and sketching effort. Origin provides easier symmetry, so we did that with a whole pattern, right? If I didn't have the origin in the middle, I'd have to construct other geometry, do mental math, add additional dimensions, do something to mirror about my center, my origin. So all of that saves us time, limits our liability, because the origin is the origin / planes. Those four base features are guaranteed reliable. Nothing will ever happen unless you physically delete the file that will make those disappear. So we have general principles. Don't do 2 of the same dimension. Equal, optimize, do something. We can do equals in a lot of things, or global variables and that kind of thing. Generally, less geometry is better. Mirroring patterning, origin, center, mass. Proper separation and concern, not too much in one sketch. So I don't really like it when I have a plate and I have to have a cutout in it. I do it all in one sketch. I'm going to draw one sketch that's the plate, and then one sketch that's my cut. And the reason is because if I don't want that cut anymore, I have to delete that cut. I drew my rectangle here. Sorry for the blip in the record there, internet. And we cut through all. This face just got fractured into 2 faces, but my mates will still constrain, and my everything will still work, before or after. So we have to understand how the software works, how the face IDs and constraints are made, and how the impact of our actions are going to affect the reliability and the buildability of that model. So that's what I would do there. And to just belabor the point somebody else mentioned about our drawing, in no way, shape, or form is that one dimension helpful, valuable, or complete for a 2D printed drawing for manufacturing. But in no way am I going to be inclined to add more than one dimension to fully define my cut based on the design intent I'm trying to accomplish. So I'm not going to go out of my way to make my 3D models worse to have a dimension show up on my 2D print that I could easily add on the 2D print in isolation. The other big problem is if I do my model items and I do import my sketches, if I want to reconstruct this and I delete that because I add an arc like this, and I'm going to add another dimension there and another dimension here, and let's say that's 3/4. I just deleted the dimension that now appeared on my 2D print. So my 2D print now is going to be having a problem, versus if I did native dimension of that 2D print and the geometry persisted, I didn't now break my 2D print. So my argument is, even if you do model items and import your dimensions, you're opening yourself up to more liability and more errors down the road, because you now have 2 disconnected things that should be disconnected from a proper separation concern thing coupled. And now your action here is inadvertently going to cause problems here. And you're just increasing your liability the more you tie things together that shouldn't be tied together.
I hear you say it's best practice not to import your dimensions from the model, but do them on the drawing instead.
Because what dimensions here are helpful for the machinist?
That's what you're saying, right? That's
None.
Best practice.
Yep, so I'm not going to go out of my way to add dimensions in my 3D model that aren't helpful. So
You typically wouldn't import any?
none.
Oh.
So, okay, so sound like a marginal hypocrite here. I actually import a lot of dimensions, but it's only because it's for homework assignments for my class, because I'm trying to communicate to them design intent. So I say the dimensions on the print are what you should use in your model,
Okay.
but this print is in no way, shape, or form a manufacturing-based print. When we make manufacturing-based prints, it's totally different. So the only useful thing I've ever found for model items is making homework. And my students can collaborate that story. All right, so if I was going to make a if I was going to make a drawing for this, it's only because I have 5 minutes left, and I'm not going to finish my PowerPoint anyway. Oh, wow. Amazing. Okay, so I'm done with my PowerPoint. Any questions? I am thinking of my assembly PowerPoint, which is more pages. Any questions? I'll talk 5 minutes on 2D print. Sir?
Keyboard shortcut you mentioned for extrude. Is
Yep.
that throughout any process and assemblies or anything you can bring it up?
Yep.
Okay.
Yeah, and there's a couple really fun bugs in SolidWorks where the feature's not available, like a balloon in a part file. Right? You can't balloon in a part file. You need a bill of material and assembly. But if you assign balloon as the command to a keyboard shortcut, you can activate that command in an environment where it's not natively supported, and you can crash things because they gray out the button,
Yeah.
but they didn't think of anybody actually assigning it to a keyboard. It's funny. Anyway, so let's pretend I'm going to make a drawing for this. All right. Well, I'm attempting to create bad examples like I would do in class. And I don't know why. I don't know what this part does. That's a really random part. If I'm going to make a drawing for this, what's the first problem everybody sees? I'm sorry? Sharp corners. Yep. Inside. Well, I could in theory do that with a bottom end mill, but let's pretend I really had to have that. We're going to wire burn it or whatever, right? Other than the geometry, to make the base for the drawing that I'm trying to make, what's the problem here? And anybody who's been in my class, don't answer because that's cheating.
You mean like no dimensions on the drawing?
No, we're not even to the dimension yet. What's wrong with just the view that I put on there?
No,
It looks
one,
2D.
It's what?
It looks 2D when it's 3D.
Yeah. So, yes, more has to be added. But what's wrong with what I've already added to date?
It's not the front view.
Front view doesn't matter.
Space
No, just okay. Ignoring everything but the view I added, like these 7 lines or however many lines there are. Okay, so who's actually ran a like a CNC, a Bridgeport, actually made something?
You don't have a date on
Yeah, but we'll add that. Of what I've added so far, what's the problem, right? How would I put this in my mill?
it. You need 2 setups. Do I have the origin set?
All right,
Or try to-
I think I'm losing it. Okay, in a mill, I'm going to put it in a vise like that. Every time guaranteed. I never hold material in the mill on the small ends the long way. Ever. Ever. Like, virtually ever. Because nobody puts their vise on the mill sideways, right? Unless it's a really special thing. So, my opinion in my class, if you give me a print like that, you're going to get points off because that's a bad print. No mill operator is going to put that like that in their mill. So they're now going to take your print and rotate it, and now everything is on its side because that's how it fits into their part, and they're going to match up the dimensions. Right? So the print is exclusively focused on giving manufacturing what they need. Nothing more, nothing less. So we have to think about that. This is still, again, limiting my liabilities. And I bring this up because it's limiting my liabilities because if I have to make my machinist do mental math, transpose the image, flip it upside down or rotate it or anything like that, and a bad part gets made because it was difficult to make based on the information I gave them, it's my fault, right? There's a liability I can limit and says, every machinist in the world makes their parts like this, so I'm going to give them a print that matches their environment. And then, yes, I do need another view. Isometrics are fun. Now my scale is too big, right? So I'm going to do all this. Second thing, and I've got 2 minutes. Where's my 0? I'm going to start making my XY dimensions. Where do I put my 0? Not Rick, because you've answered too many times. Anybody else? I'm sorry? Why the top left?
Put it in the mill, put it in
Because
the top.
anybody who's ever ran a mill understands two things. The vise on the mill that doesn't move is in back. And when I put a part stop in, where do I put my part stop?
Usually on the left.
On the left. So when I come in the morning and I tram out my mill and make sure it's all square, and I find my zeros, I'm going to take my edge finder and find the back of my vise and the side of my stop. And then a smart engineer who has a degree gives me a print like this. And what's the mill guy going to do? Take the print, flip it 180, interpolate all the dimensions invertedly, and attempt to make you a good print. Or, what's worse? Yeah. Okay, so that's really frustrating. Or what's worse is this, right? He would have to flip it upside down and look at it through the lights to match his mill setup. So, from a liability standpoint, what are you doing to your shop floor when you give them bad manufacturing prints that aren't matching their environment?
Increasing potential for errors.
You are increasing your liability.
You're checking how good they are.
I'm sorry?
You're checking how good they are.
Now, I mean, there's a whole conversation to be had if it's a CNC and do they really use the print and a bunch of other things. But universally, you're going to put the ordinates top left. And the only exception to this is if you're going to flip the part enough times and you need to maintain your universal zero for accuracy. But if you're just like, if it's a hole to hold a bracket to hold a sensor or something, right? You don't really care, so then you can just keep doing that. But if the machinist can put a part in his mill and not have to pick up zero every time, you're going to make more money, make better parts for less money, be more profitable, etc., etc., etc. So, my hour is up. I've rambled a lot. Hopefully everybody learned something. Any questions? We'll go back to... There's my contact info. And I'm back here again for the second session talking about assembly tips and tricks. It'll be a continuation of this thought in some capacity. Just assemblies. Any questions? Any comments?
Is PowerPoint available to us?
Yes. So roughly a week after today, all of the sessions will be recorded and put on YouTube with all the supporting materials. So you can download all the files I made, the PowerPoint, and watch the same lecture.
What is smooth logic? What is it?
Well, I can talk to you about it later, but
Oh.
any questions? We got to go back up front. All right.